My name is Kwang Lee, and this video is for CSC 313 final project. Our team's project name is Late2Work. The project is about a high-speed car game navigating through traffic and avoiding other cars and reaching the destination. And let me show the gameplay. So we start by setting up the game using the game library. This includes setting the OpenGL version, disabling resizing, and making sure the window up and center, as you can see in this video. And we also enables an ESC key to close the game. And we configure the OpenGL to clear the screen with the sky blue color and enable depth testing so that closer objects are drawn in front of further ones. And we set up the camera and projection matrices. This determine how the 3D world is viewed from the player's perspective and how the perspective scales and angles look during gameplay. And the camera automatically follows the two players. And as you can see, there are two cars in the middle, blue one and the green one. So player one is blue and player two is green. And before we load 3D models, we double check the car OBJ files exist. If any are missing, we notify the user to prevent loading errors. And yeah, this is the gameplay. And we also have a cleanup function. So when the game is over, it's gonna clean up all the data we used in this game. So make sure uh, we don't have to save any data for the storage in the storage. So and and what makes this game over is to hit the uh, middle part of the car, which is really small. It's the size of the red car. So let me go over the code line by line for my part. So as you can see, this is my name, uh, Hang Lee, but I use Brian for this project, and it's purple. So let me go to my part. This is my teammate's part, and my part starts from here. It's a setup window. So this function creates and configures the main GLFW window with an OpenGL context and input callbacks. So, so error callback and dot create print, it sets up an error callback to print GLFW errors to the standard error stream and just prints a log message indicating that GLFW initialization is starting. And in this if statement, initializes the GLFW, throws an arrow if it fails, and printing out printing out if it succeeds. And this is reset. This resets the window hints to default values. And for this part, request an OpenGL 3.2 core context. This is needed for macOS compatibility. And for this, like GLFW false and visible GLF visible false. What this do here is hides the window on creation, making non-resizable, and we print out the creating window. And for this window, it goes to creation window with high title and no attempts to create a GLFW window. And for this if statement, if it's window equals to no, drove new runtime exception, failed to create GLFW window. So uh, if creation fails, it throws an arrow, and otherwise, success like successful like log is print out, and this set key callback sets a callback, so the uh, ESC key escape key will close the window when released. And yeah, as you can see, key escape set to true, should close. And this try, if the memory stack is equals to stack push, uses the memory stack to retrieve the window size and center it on the screen. And for this part, make contact current to window and swap in interval to 1 and make the show window to window and print out the log that window setup complete. This makes the OpenGL context to the current and enables the vsync and show the window and log setup completion. And now is the function of setup OpenGL sets up essential OpenGL features like depth, testing, and background color for 3D rendering. Uh, and so this is pretty short. So for the first line, create the capabilities, initialize the OpenGL bindings for use, and sets the clear background color to sky blue. And this is depth test and texture 2D, enables the depth testing and 2D texture. And now the setup matrices. This function utilizes the camera projection and orthographic matrices for rendering 3D scene and 2D overlay. So, so for projection matrix, set it to buffer units to create float buffer to 16, and other view matrices to also set it to 16. Allocate the float buffer for projection, view, model, and orthographic matrices, and aspect to width divided by height. And this is all mesh kind of thing. So sets up the perspective projection matrix using the FOB and aspect ratio. And this projection matrix put manually bind the projection matrix. And this also metric put builds an orthographic projection metric for 2D overlays like text or UI, and update the view metric, calculate the initial camera view metric, and now update view matrix. So this function calculates a dynamic camera view that follows the average position of two players. So yeah, this is all about the camera position. So this creates a camera view matrix looking at the player. So first, this where is it? So this IXYZ is calculates the camera position based on average player position, and for this F computes the forward direction F and normalize it, and this S and U uses cross production to drive the side vector S and up vector U, and fill the view. I mean, this fills in the view matrix with the lookup transformation. And next is setup shaders. It defines the GPU shader programs that control how objects are drawn and shaded. So this vertex shader source and fragment shader source defines a GLSL source code for vertex and fragment shaders. Yeah. And there's more in the bottom. Okay, now it's check file exists. So what this part doing is checks if required 3D model files like OBJ exist to avoid loading errors. So uh, it's it's just checking like checks if both out like uh Audi obj and truck obj file exists in the assets directory, and prints the message to the console to show whether each file was found. And see if it's missing, it's gonna output those, and if it's found, it's gonna print out this, and it returns true only if both files are found. And next is update model matrix. So This function builds a transformation matrix to move and scale objects in the 3D scene. So this function builds a transformation matrix that translates and scales an object in 3D space. So the values are stored into model matrix, which will be used in the shader to transfer geometry. Yeah, this is all the values. And last part of my code is cleanup. It relays all allocated graphics, audio, and window resources before closing the program. So the reason why it's like cleaning up is uh it's trying to because we're not like saving any uh data, so it's gonna save the uh storage and if you like save all the file, it's gonna take it's gonna make really big file. So that's why we have the cleanup function. And this is it for uh final project video. Thank you for listening.